So here is example problem number 1. Sine squared 2 theta equals a half. I want to know what thetas work between 0 and 360. In all of our examples today, I only want the answers on the first go around the circle, because we could go around forever and have an infinite amount of answers if we were doing all the angles that were bigger than 360. So what I'm really asking is, what would I put in the box to make the equation true, if you like the old kindergarten box, instead of the variable? Sine squared of 2 times what equals a half. So all we're going to do is like we did in regular algebra equations, we're going to peel away little by little until we just have theta. First thing we need to get rid of is the squared. Okay, that's squared. We're squaring sine of 2 theta. So it could also be written like this. The squared's written in the middle for a trigonometric function, but you could also write it kind of on the outside if that makes more sense to you. How do you find a square? Square root. So we're going to take the square root of both sides. We take the square root of a square, it goes away. The square root of that right side becomes plus or minus root 1/2. Okay, and that'll never do. Can't have root 1/2. So we have to go through that process on the right side. So we have root 1 over root 2. Root 1 is 1. And when we rationalize the denominator, we would get root 2 over 2. Skill that we learned first semester. So our equation at this point is sine of 2 theta equals plus or minus root 2 over 2. So that was step 1, taking the square root of both sides. The next thing we want to do is get rid of the sine. And we want the theta to be alone. Here's how you get rid of a trigonometric function. You basically go to your unit circle and you say, where are the sines plus or minus root 2 over 2? So you're looking around for any y coordinates that are root 2 over 2 or negative root 2 over 2. And that's going to become the other side. So that's going to be 2 theta equals 45, 135, 225, and 315. Those are the angles on the unit circle whose sine is root 2 over 2 or negative root 2 over 2. And now the final step to get the theta by itself is to divide by 2. So we're going to divide all those angles by 2. 45 divided by 2, 22.5. And then you just keep on going, dividing them all by 2. But there's an issue with this one. I'm not happy with the results because the question says I want all the answers from 0 to 360. And look at my answers. I feel like we stopped short. So the general rule is, if you have a coefficient in front of the theta, like we have here, 2 theta, when you are writing these angles, you need to go this many times to the coefficient of the theta. You need to go this many times around the circle. We only went once around the circle when we wrote those answers. But you want to go that many times around the circle. Here's why. If you go around again, you'd get 405. That's 445 plus 360. And you divide it by 2, you're still under 360. So that's an answer that works. And then there's the rest of them. Adding 360 to the original 4, and then dividing those by 2, 202.5, 247.5, 292.5, and 337.5. Those are all legitimate answers that are less than 360. Let's try a simpler one. See if you can do that one by yourself. The first thing, you're going to get rid of the sign. That's the outermost piece of that left-hand side, so that's what you get rid of first. So you look at your unit circle. What angles have a sine of a half? That's going to be 30 and 150. And then you multiply those by 2. 60 and 300. In this example, first thing you do is figure out where the cosine is negative root 3 over 2. And it's at 150 and 210. But since it's 2 theta, I'm going to go around twice. So I'm basically going to add 360 to those two angles and get 510 and 570. And I'm going to divide all those by 2, giving me 75, 105, 255, 285. So we're looking for when is the tangent 1? Well, tangent is sine over cosine, TSC. So sine divided by cosine has to be 1. That means that the sine and the cosine have to be the same number. So you're looking for anywhere in the unit circle where the sine and the cosine are the exact same number. That is, of course, 45 degrees and 225 degrees. I will then multiply those by 3 to get 135 and 675. At the beginning, I told you we were restricting our answers to 0 to 360. So 675 is too big. So the only answer is 135. This one should have a lot of similarities to another problem we did today. You should have added 1, divided by 2, then taken the square root, which we already know will simplify to plus or minus root 2 over 2 because we already did that today. And that's the 45s. In this example, we have a huge problem. And the problem is the angles are different. So we have a cosine 2x equals a cosine x. Right now we have apples and oranges going on, which can't happen. So we have to do something that gets us apples and apples. We have to make a change in the problem so we don't have a 2x on one side and an x on the other. And so what I'm going to do is I'm going to go to my Courtney Pierce and I'm going to find a double angle formula that has just cosine in it. And I think it's the bottom one. And if you do look at that, you'll see that it is 2 cosine squared x minus 1. Okay? Now, what we have here is a simple quadratic equation that you might not be able to see because of the scary trig functions. So what I'm going to do is I'm going to get rid of the trig functions for a second, just like I kind of did at the end of the last example. And I'm going to take out the cosines and I'm going to put in an a. So everywhere I see a cosine, I'm putting in an a. So instead of having 2 cosine x squared, I have 2a squared. And so now we're going to solve that quadratic with an a because you might be more comfortable with that. And then at the end, we'll go back to cosine. So we're going off to the side, and we're going to solve for a. I'm going to move things around. Now I have a quadratic. We can factor the quadratic using the monkey method, which you should all be very familiar with. factors into 2a plus 1 and a minus 1. Or a minus 1 and 2a plus 1. Using those two parentheses, I know that the solutions are for a, negative 1/2 and 1. If you need help on that right side, you need to go back and watch a video from chapter 5. Okay? They're still on the Google Classroom. Scroll bar on your mouse. Scroll. You'll find it. Go watch it. Okay, so I have answers for A. Is that what I want? At the beginning of this problem, did you say, man, I wish I knew A? No, you didn't have, there was no A at the beginning of the problem. We want to know what X is. So I'm going to go back now and I'm going to put cosine X in for A. Just like a few steps ago, I put A in for cosine X. They're the same. The only reason I did that was for those of you who were confused and could not see the quadratic through the trigonometric functions. So I got rid of them. Took you back to chapter 5. Now we're back in chapter 14. So now I'm going to do the trig functions. What angle has a cosine of negative 1/2? And what angle has a cosine of 1? So you look at your unit circle. Cosine of negative 1/2, 120, 240. Cosine of 1, 0, and 360. Sine of x over 2 plus cosine of x equals 1. Awful mess. It's got two trig functions. It's got two different angles. It's just an absolute travesty. So we have to find some way to get one trig function and one angle. Does anybody have a suggestion at all? Gritch?
I will replace the sine of the x over 2 with plus or minus.
Okay. So his suggestion is replace sine of x over 2 with the formula for half angle. Okay, you can do that. So I have plus or minus the square root of 1 minus cosine x over 2 plus cosine x equals 1. Good. One step, and I have all cosines and all x's. When you have one trig function and one angle, you can turn it into, you can get rid of the trig functions and make it an A. So that's what I'm going to do right now. Took out the cosine x and made it an A. At this point, we are no longer in the trigonometry chapter. We are in some Algebra 1 chapter. I want you to spend a couple minutes and see if you can solve for A. Step 1, the way I did it was I moved the A that's not under the root, I subtracted it to the other side. The reason why I did that is because at some point I'm going to have to square both sides. And when I square both sides, that root has to be by itself. If you're just going to square that left side and square the root and then square the A, you're making horrible math mistakes. Because that is not how you square a binomial, which you'll see in a minute. So now I'm going to square both sides. The left side becomes 1 minus a over 2. The right side becomes 1 minus a times 1 minus a. You don't just square the 1's and square the a's. That is not how you FOIL. You have to FOIL the parentheses. If you take 1 minus a times 1 minus a correctly, you would get 1 minus 2a plus a squared on that right side. If you try to do that up here with this, that would be a disaster of trying to foil that. It would be a big mess. So that is a bad idea. Bad. Okay. I'm going to multiply both sides by 2 to get rid of the fraction on the left. I'm going to then add the a and subtract the 1 to the other side. So everything's on one side. When I do that, on the right side, I have 1 minus 3a plus 2a squared. And if I rewrite that in order, I have 2a squared minus 3a plus 1. Monkey method. We'll factor into 2a minus 1, a minus 1. Giving me answers for a of 1/2 and 1. We're not looking for a, remember. We are looking for cosine, we're looking for x. A is equal to cosine of x. So we're going to make 1/2 and 1 equal to cosine of x. Cosine of x is 1/2. That occurs at 60 and 300. Cosine being 1 occurs at 0 and 360. The only issue left in this problem is the fact that you squared both sides. And squaring both sides is like leaving the back door open. Little critters can get in that you don't want in. In our case here, false answers. So what you have to do is you have to check your answers. So you'd say, you get out your calculator, that'd probably be quickest, and you put in 60. So you go sine 30 plus cosine 60, and you check and see if it's 1. Sine 150 plus cosine 300, and you check all of them to make sure they're 1. In this case, all 4 work just fine. They're all good. Okay. So